today's video, it's not really about this question, because the question is not too difficult, I think. This video is more about a method to do things like this question easily, quickly, and without making mistakes. We are going to see a little bit of theory, then we are going to see many examples for you to work through them. First point is that two hydrogens are lost when a cycle is made. For example, we have here propane with 3 carbons. Then when you make cyclopropane, you are going to lose these 2 hydrogens, which come out as hydrogen, H2. So you go from H8 to H6 by forming a cycle. That's really important. When you make a double bond, the same thing happens. We are going to make a double bond between these 2 carbons. So again, if you don't take 2 hydrogens away, then these carbons, they just have too many bonds, so they have to go. And then if you make a double bond between a carbon and an oxygen, really important, you also have to lose 2 hydrogens, because otherwise, again, you just have too many bonds. So you see that you go from H10 to H8 to H6. And I would like you to bear this in mind for the examples we are going to see. Let's start with this one, which is not too difficult, but the key is not to get the answer, is to learn the method. How many carbons do we have here? We have 3. That's the only thing you have to count. For the hydrogens, you don't have to count. You do it this way. There are no double bonds, no cycles. So then the number of hydrogens is 2n plus 2. And therefore, that gives you 8. So it's C3H8. You count the carbons, but you calculate the hydrogens. You don't count them. Let's do this one. Same thing. You count the carbons, 3. No double bonds, no cycles. So then how many hydrogens? Well, H2n plus 2, which is 2 times 3 carbons plus 2, 8. So this is C3H8, and now you do have to include the oxygen. And some people tell me, but sir, are you sure about this? How can it be the same hydrogens if you have an alcohol? Maybe you have one more. But I'm just going to prove it to you it's the same. This is propane, 8 hydrogens, and this is propan 1-ol. All you do is that you shift this hydrogen to the right and you stick an oxygen in the middle. This is now going to get more interesting, I think. Do you want to try this one? Pause the video. We have 11 carbons. Therefore, it's going to be 2 times 11 plus 2, 24. There you go. You see, it's very, I think, quite quick, and you shouldn't make mistakes. Some people start drawing the hydrogens here, then counting, and then they are tensing the paper because they are running out of time. Then they count again, and you don't want that. So that's why the method is helpful. Okay, now you have a cycle. You have a cycle. So you want to try? You have 7 carbons. Potentially, you have 2n plus 2 hydrogens. That's 16. But because you have a cycle, you have to take away 2 hydrogens from 16. That gives you 14. And that's it. That's your formula. This is the exam question we saw at the beginning. But I'm going to give you harder questions. This one. You want to give it a go? Pause the video. So 12 carbons, 2n plus 2, that's the potential number of hydrogens, 26, but now you have 2 cycles, so you take away 4 hydrogens, H22, so C12, H22. Next one. This is more interesting because you have 1 cycle and 1 double bond. Remember the introduction of the video. Give it a go. Okay, so 7 carbons, potentially 16 hydrogens, one cycle, one double bond. Take away 2 hydrogens for each cycle or double bond, which means 12. Therefore, C7H12. And another one. There you go. So 10 carbons, potentially 22 hydrogens, one cycle, one double bond. So take away 2 hydrogens for each of them, and that gives you C10H18. You want to try this one? This is even more interesting, maybe. So 7 carbons, potentially 16 hydrogens, 2 double bonds, so take away 4 H12, and now you simply add the oxygens, so O3. This one, you have a little bit of everything. Double bond, cycle, oxygens. So 8 carbons, potentially 18 hydrogens, one cycle, 2 double bonds. So you have to take away 6 hydrogens, so H12, and then 3 oxygens, and there you go.